Hello everyone, today we're going to discuss the quick solutions to the chemistry section of All India Akash Test Series JEE Advanced 2020 Test 3A Paper 2 Code E and F. So students, the first section contains 5 questions. Each question has 4 options, out of which only one single option is correct. Okay, so let's start with question number 21. It says, for which one of the following pairs the metallic radii of the first element is higher than the second element? Okay, so the elements of the 4F series have been given to us, students. So if we talk about the 4F series, we can just write it down. So if we talk about the variation of size from left to right in these elements, students, the variation in size is almost uniform with the exception of europium. So europium has the greatest size in the 4F series. So it has the largest size. The others generally follow the trend of decreasing radius as we move from left to right. Okay. So if we talk about the first option, so EU and LA. So obviously EU has a greater radius than LA. So this is correct. If you talk about the second one, so TM lies towards the end, whereas SM lies towards the beginning. So this cannot be correct, students. The size of SM is greater than TM. Okay. If you talk about the third option now, we have YB and GD. So GD is towards the left, whereas YB is towards the right. So again, GD will be larger in size as compared to YB. So GD is more than YB. If you talk about the last one, we have SM and PM. So PM has a greater size than SM. Okay, so only the first option, it contains the elements in which the first element has a greater radius than the second element. So for question number 21, we have to mark the correct answer as option A. Let us look at the next question now. Question number 22. Identify the compound which does not show color due to charge transfer from ligand to the metal. So if we talk about HGS is colored due to charge transfer. KMnO4 is also colored due to charge transfer. TiO2 is colorless, so this has to be the answer. If you talk about CDS now, CDS is also colored due to charge transfer. So out of these given compounds, only TiO2 does not have a color. So it is going to be the answer. So for question number 22, we have to mark the correct answer as option C. Let us look at the next question now. Question number 23. Consider the following reaction. So we've been given a compound R, which is a cyclic compound. Its formula given to us is N3P3Cl6. It is allowed to react with 6 moles of HNMe2. So this is a secondary amine. So after the reaction, it is given to us that this secondary amine, it substitutes 3 chlorine ions or 3 chlorine atoms from the compound R to give the compound Q, whereas 3 Me2NH HCl is formed. Okay. So some information has been given to us. Molecule R has alternate NP-N bonds. Molecule Q has same arrangement of N and P as that in R. Okay. So molecule Q and R both contain alternating N-P-N bonds. Okay. We have to comment on the total number of possible isomers, including stereoisomers for the compound Q. Okay. So if we talk about the compound R, students, the compound R, it is mentioned to us that there are alternating single double bonds between N and P. Okay. So if we talk about the 6 chlorine atoms, they will be on the phosphorus as nitrogen cannot expand its octet. Okay. Now this is the compound R when it is allowed to react with NHMe2. So it is given to us that we have to substitute only 3 chlorine atoms. Okay. So if we talk about the substitution now, students, the substitution can happen geminally, that is at the 1,1 position, or it can happen at the 1,3 position also. Okay. So we have to cause the substitution of 3 chlorine atoms. Okay. So we can draw the cases, students. We can have this case in which both the chlorine atoms present on one of the phosphorus atom is substituted. That is, it is a geminal case. Okay, so this is one of the isomers which will be obtained, students. And if we talk about this compound, we can clearly see that this compound is optically active. So it is optically active, so it will exist as a D plus L pair. Okay, we can have other case as well. So we can have another case in which there is a substitution at the 1, 3 and the 5 position. Okay, so we can have the case in which all the NMe2 groups are cis with respect to each other. Or we can have another case in which only one of them is at trans with respect to the others. Okay, so we can have another structure. So I'll draw it here. So this time we have to have only one of them as trans. Okay, so there is no other possibility. We just have to check for the optical activity of these given compounds. Okay, so we can just separate them. This was the first, it existed as a DL pair. Now if we talk about the compound which we had drawn on the right, we can clearly see that this is going to be optically inactive as there is a plane of symmetry represented in green. Okay, so it contains a sigma, so it will be optically inactive. Okay, and if we talk about the last compound, this compound will also have a plane of symmetry. So this plane which I have drawn in green, so this is going to cover both this NMe2 as well as the Cl groups, and the other atoms will be symmetric about this plane of symmetry. Okay, so this will also be inactive. Okay, so we have a total of 4 stereoisomers possible for this structure Q which is given to us. Okay, so if you look at the options, we can clearly see that for this question we have to mark the answer as option A. Let us look at the next question now. Question number 24. The number of lone pairs of electrons on the central atom in Br(F4 negative, XeF6 and SbCl6 negative are respectively. So we just have to draw the structure of these compound, students. If we talk about Br(F4 negative, so bromine has 7 electrons of its own. There is a negative charge which has to be occupied by the bromine atom. So bromine will have 8 electrons. 4 of them will be bonded, whereas the other 4 electrons shall be in the form of 2 lone pairs. Okay, so if we talk about number of lone pairs over bromine, it is equal to 2. Okay, if we talk about the second compound now, XeF6, so XeF6, Xe has 8 electrons of its own. 6 will be bonded to fluorine atoms, whereas the other 2 electrons will be in the form of a lone pair. So this is a capped octahedral or the distorted octahedral structure, students. There is one lone pair present on Xe. If we talk about the last compound now, SbCl6 negative. So Sb has to accommodate all the negative charges if we talk about the covalent bonds in the system. So Sb has 5 electrons of its own. Okay, and there will be 3 additional electrons. So Sb will be having 8 electrons in it. So 6 will be bonded to the chlorine atoms. And there will be one lone pair of electrons over Sb as well. So this has one lone pair of electron again. So if you look at the correct combinations of lone pairs on the central atom, we can clearly see that we're going to have to mark option D as the correct answer to question number 24. Let us look at the next question now. Question number 25. The total number of stereoisomers of the complex M, A, B, C, D, E, F is. So students, we know that the number of stereoisomers possible for the complex M, A, B, C, D, E, F is equal to 30. So there exist 15 enantiomeric pairs. Or a total of 30 stereoisomers. Okay, so the correct answer to question number 25 has to be marked as option A. Let us look at the next section now.